Okay, next step of this horrible assignment. Calculate the probability of the occurrence of each colors. So we got all the colors, we know which pixel is which color, and we know how to figure out the color, if it's red or green or whatever. So it's actually quite easy to figure out this. So I'm going to open up my original one. I already did this. And I figured out a bunch of different colors which will help us check if it's working properly. I'm just going to copy paste this over. Test 3. So I'm going to run this one more time and find my rainbow. And if I come back to MATLAB now, it's printed out my little list of colors, which is good. It's handy to have. So, what's next? Firstly, I'm going to multiply. Actually, no, I'm not. That's stupid. Alright, I'm going to make an array to save all the pixels in. Sorry, not all the pixels. I'm going to call it frequency. And it needs to have 8 spots because there's 8 different colors. So each spot will be a number or a percentage, which tells me how often each color occurs. I'm going to initialize it by just making it all zeros. I'll populate it later on. 8. So it's going to be a 1 by 8 matrix. That should be good. Let's just make sure that's working first. Yep, so frequency, all zeros. Frequency. Yep, that's all good. I'll change those numbers later on when I calculate the probability. So, the best way to calculate the probability is by writing a for loop and going through and checking every single pixel. So, the syntax for a for loop is for some number, say a, equals 1, and then I need to do it the loop for this loop the amount of times for each pixel. So because the image is 490 by 256, the total size is going to be 125,440. Now as a quick way to get this, you can type numL, which stands for the number of elements, and then you can type in your array. So mine was new image. I'm going to say total pixels equals number of elements. So the number of elements in this image. Just comment this out for now and make sure that is working, or we can't go any further. Back to MATLAB, and yep, that's the amount of pixels, 125,440, which is as expected. So I'm going to loop through this that many times. Total pixels. So I'm going to say the color. So this is going to change. Color is going to be equal to new image sorry. So the way this is going to work is A is going to increase by 1 every time this loop completes, all the way to 125,440. And then each time I'm going to go to the next element of new image. So it's going to be whatever number is saved in that element. So for example, if we go back here, we go new image 1, 1. It's going to be 2. Then on the next iteration of it, it's going to go to new image 1. And the next iteration is going to new image 2, which is also a 2. I'm going to get a lot of 2s because it's the whole top row of my image is all. So the way MATLAB saves matrices is in a big long row. So it's going to go all down the first column, then all down the second column pixels. So I'm going to get heaps of reds, then heaps of oranges, then heaps of yellows, and all the way to the end. So that's all good. So this is going to print out a different number each time. So if I just do it, say, for the first row, which has 490 pixels, we can see the results. I'm just going to leave this off so it prints it out. F5. Get my image. Boom. So if we go back to MATLAB, 55555. So it's printed out the entire first row, which is a bunch of 2s, which corresponds to red, as we calculated before. Then after a while, it's going to change to 6s, which is going to correspond to orange, then down again, 3s, all the way down to the end of the first row, which is 5s. Then it'll reset. So new image 491, we're back to 2, which is up here, and it'll go down again. So let's clear that for now and come back to the script. Cool, so we know how to check every single image, every single pixel, sorry, total pixels. Now we need to determine how often each one is occurring. So I'm going to save them into the frequency matrix we set up here. So frequency, how are we going to do this? Sorry, just thinking about this. So frequency color, which is going to be whatever is indexed by this, so 1 or 2 or 3 or whatever, is going to be equal to frequency. But, sorry, this is really confusing, but if you go back to MATLAB, we know that it starts at 0, not 1. And matrices start at 1 for the first element. So we need to add 1 to this. For example, if we got to a 0 in new image, then you can't access 0 of an array. If you try and do that, it doesn't work. You have to get to 1. That's where the image starts, 1. So we have to add 1 to that number to make sure we get to the index. So that's going to be equal to the color we got, or whatever color came up. So 8 colors. Wait, what was the name of our frequency? Sorry. Frequency color plus 1. And then we're going to add 1 to whatever number comes up here. So every time we go through, if we get like a 2, then we're going to go, if we hit 2, we're going to go, yep, 2 or 3 is going to be equal to that number plus 1 extra. Then if we get another one, we're going to add 1 more. And if we get another one, we're going to add 1 more. And we're going to keep on adding numbers up. So this is going to go through the entire image, which is 125,000 times or whatever, and add 1 on for each number we hit. So that should return how often each color occurs. So I'm going to try it. Sorry, it's a bit confusing. Hopefully you figure it out. But if we go back here, see, it's run. So all these numbers have been populated. Frequency. Here's our numbers. So we've got the first color occurs 1,000 times. The second color occurs 18,000 times. The third color occurs 17,000 times, and so on. Now let's check out what colors those correspond to and see if it's actually worked correctly. We've called it new map. So the first color, this color, occurs 1,065 times. And as we said before, let's go ahead and multiply this by 255 so it's easier to see what they correspond to. Here we go. So 12, 14, 7. Now I've got my little list up here. Black is 0, 0, 0. So that color is pretty close to black. It's not a very colorful color. It lacks in red, green, and blue. So according to this, black occurs 1,065 times, which looks like it's probably about right because there's not very many black pixels in this image. And if you look at the other colors, which are going to correspond to whatever color up here, orange, yellow, green, blue, black, white, they all occur around 17 or 18,000 times, which again makes sense because each one of these colors appears to occur approximately as frequent as the others. So each one of these takes up approximately 1/7 of the image, but black takes up only a very small amount, 1,065 pixels. And you could easily convert this to a percentage by grabbing a number, dividing it by the total amount of pixels, which is 125,440, then multiplying the answer by 100. So black takes up 8.4% of this image, which looks about right. I'll just double check it with, say, another color. So what about